Hey, how you doing? I guess I had to click broadcast. I was sitting here waiting unless you just now came on. How are you doing, Annie?
I'll come back later. Need to get some dinner.
How are you doing?
Good.
Good. So it's automatically clicking over when we talk, huh? Interesting. Okay, so say something. I want to see if your picture comes up when you say something.
Hello.
No, I didn't swap. It was probably me. There we go. So, did everything go okay with your homework and everything on Tuesday? So everything was okay?
Mm-hmm.
Okay, good.
So did lesson 7 homework, but I'm wrong, but I don't know how to get the right answer.
Yeah. Lesson 7 was a little bit more difficult for me.
Especially the last 2 questions. I don't know which part did I do wrong.
Oh yeah, seeing with the probability, basically what that is focusing in on is you have to get the z-score.
The problem is, that in the textbook it gives the example of how to count the probability with that graph, and then you just enter the areas, number of the area, that would be the answer. But actually the right answer should be divided by 2, because the area is both negative side and positive side, so you need to divide it by 2, then you get the right answer. Sometimes the textbook just confuse me.
Yeah. And how it's worded.
Say you need to divide by 2.
So between, and it's the wording too can be, you have to pay super careful attention because it could be between or above and below, or you have to,
or greater or less, or
yeah. What was helpful for me is watching the videos. Have you had a chance to do that yet?
Yeah. Oh, I haven't watched a video for lesson 7, but I watched the lesson 6.
Now, are you at BYU Idaho then?
Yeah.
Okay, so, and what my daughter, I can't remember what dorms she was in. I can't remember the name. So what dorm are you in?
I'm in Normandy. It's just by the stadium.
Okay. Yeah, she was, and so you're on the campus dorms, or are you, okay. Do you like it?
Mm-hmm.
So what year are you?
It's freshman.
Oh, you're a freshman.
First year.
Okay.
It's just my second semester.
Second semester, and then what are you majoring in?
Business management.
Okay.
As an entrepreneur management.
Okay. Me too. So when are you going to be all done with your degree?
I don't know yet, because I'm planning to serve the mission next year.
That's exciting.
Yeah,
Oh, how wonderful. So when did you decide that?
this semester.
Wow. So and do you
Because my my boyfriend is going to serve a mission this end of this year.
oh really? Okay, so you guys gonna go out about the same
Yeah,
time and then you'll be back 6 months before him.
yeah.
Yeah, keep you busy, huh? My son's in St. Petersburg, Russia right now on his mission. Yeah, it's just amazing to hear everything,
Hmm.
his experiences. It's tough. You know, some countries there are a lot of baptisms. One of his good friends is
Hmm.
in Texas, and tons of baptisms in Texas. And my son,
Hmm.
no baptisms. He's been out
Oh,
about 10 months, and they work a
wow.
lot with members, like members who aren't
Hmm.
attending or have become inactive, that kind of thing. They do a lot of service because they can't go proselyte anymore. They passed laws where they can't go out and knock on doors, and
Oh.
yeah, they can only teach at the church. So it's very different for them now.
Hmm.
So where do you want to go?
Um,
Is it
I
time?
want to.
Where's
Yeah,
Bat?
I want to go to Britain.
You want to go where?
Britain.
Oh, really? Have you been before?
No, usually Chinese will send to Australia, Canada, America, or Britain. These four places.
Ah, okay. Wow. So that'll be interesting.
Hmm.
All right. Well,
Um,
shall we start?
it, or maybe wait for 5 minutes. I'll be back in five
Okay.
minutes. Cause
Okay. Sounds good. Okay, there we go. Oh, here we go. Add circles. Two, two, one. Okay, three. Okay. Hmm.
Jewish staffers?
I don't see
Or
that.
only 2 of us.
I know. Okay. More careful. Sorry. All right. All right. I don't see anything from. I don't see anything from Beth. Oh, there she is. Okay.
Hello.
Hi.
Hi. Sorry.
That's
Hi.
okay. All right. So, okay. Anybody want to offer the opening prayer? Okay.
Heavenly Father, grateful for that we can here to study the this is lesson together, and we ask you to bless us with the Holy Spirit and guide us online and able to figure out all the lessons, and we pray this in the name of Jesus Christ. Amen.
Amen. Thank you. Do we want to use the test as kind of our learning time?
Yeah, we can do that.
And as if we're stuck on something, we can walk through it. And is that okay?
Yeah.
Start the quiz first.
Yeah, I'm thinking, we could just go step by step through the quiz. And if there's something that we're stuck on, we can talk through it together.
Yep.
Was there anything you got stuck on the preparation?
Yeah. I think I've got it okay after watching the videos and stuff, but I mean, this is going to take a little bit of time, I think, the quiz. And that's why I think wanting to kind of jump into the quiz, because we can find those trouble spots as we go through.
Okay.
I have a feeling it'll be a while, take some time tonight.
Okay.
I got to pull up the applet. Dang it. That's one thing I forgot to do. Okay, so let's see. Applet. Do you guys have your applet open?
Open.
All right, content.
Are we recording?
Yeah.
Okay.
All right, so lesson 7, whoops, individual prep is what I needed. Okay, let's see. All right, and the applet's in the homework book. I mean, in the book, textbook. Okay. All right, is that it?
I have the one in lesson 5 has the applet. I couldn't find another one.
Oh yeah. See, I'm trying to click on those and I can't. Okay, interesting. Of course, okay. You'd think that they'd have. Okay, exam recent changes. I wonder if it's in resources, because I could have sworn I saw them
I thought
access it or something.
Yeah, I thought I saw that too, but I couldn't find it, so I just opened the one in lesson 5.
Okay, academic supports the library research, copyright, online textbook, lesson PowerPoints. Okay, so you just went in and got it from. All right, special pages. Let's see, recent changes, exam reviews, data.
There's the applet is on the quiz. When you open the quiz, there's a link to it too.
Oh, okay. All right. I was just gonna click on something really quick. Page tools. What's okay? No, that's something different. Okay. All right. So
After the first two questions, there's the information section, and that has the applet link.
Okay, gotta get to the quiz. All right. All right, so we are
Do
on
you
the
have it, Annie?
lessons. Okay, lesson 7 group meeting quiz. Okay, start quiz. Okay. All
I
right,
want some noodles. Are you eating noodles?
Yeah, I had a yakisoba bowl tonight. It was so good. Okay, I just opened the applet. Okay. Is this it right here? Okay. All right. So, while you were required to work to that, okay, when calculating anything, okay, question 3. Use the normal probability applet to find the combined area under the standard normal curve that is the right of z, it is to the right of z 1.358 and to the left of, okay, and so basically,
Combined
dang.
to the right and to the left.
Okay, and I need
To the
you.
right and to the left. So 1.358.
Okay.
An area of 0.1745 if I have both sides highlighted.
Yeah, that's what I've got too. This is okay, so 3, so it's 0.175.
0.175. 0.175.
Oh, they're saying they want the 0. Okay. 0. Okay. At the end of 0 point, and then you would enter 0 point. Okay. All right. Question 4. Which of the following will have a smaller standard deviation if 9 observations are randomly drawn from a population? A distribution of the distribution of the sample means the just. Okay. So the distribution of the sample means would be a smaller. Wait, okay. Have so much if.
Yeah, it must be smaller than the standard deviation.
I can't hear you, Annie. Can you talk louder?
No, I just said have a smaller standard deviation. It should be the distribution of the sample
Of the means, yeah.
mean.
Okay.
But I thought standard deviation. Smaller standard deviation.
Oh, wait,
9
okay, sorry.
observations are in.
Smaller standard deviation, yeah. So the sample means, okay, the distribution of the sample means the distribution of the individual observations. So the distribution of the sample means will be it means a larger group, right? Which over time normalizes, and the only number in a normal distribution that really changes is the standard deviation, and the larger it goes, the smaller the standard deviation is. Is that what you guys are getting?
Yeah.
But okay, but I don't understand what they're saying when they say the distribution of individual observations. What do they mean by that?
So that would be your sample population, right? I think that's what it's meaning. And the distribution of the sample means that's the average of all the sample populations, the individual, like the different groups of individual observations. So they've done it several times over. And now it's a combined, it's growing. Their sample has grown larger, basically. And the means, so remember that tool we used where he kept clicking it and adding more, and then as he added more of the samples, it showed the distribution becoming more a bell curved, a normalized. And
Oh,
so
right.
that is an example, picturing that in your mind, of the distribution of the sample mean.
Okay.
Is
Okay.
that, and then as that normalizes, the distribution, the standard deviation shrinks. It gets smaller.
Right. Okay. With that, any? Are you good?
Let's hope. Beth,
Okay.
you want to do 5?
Yep. Number 5. Which of the following results implies that the spread of X, right? The spread in.
Well, the
mean.
Yeah, that's the mean of multiple.
The sample mean.
Yeah, the sample mean. So that's, so you've got, so the mu is for the individual. That's the mean of the sample population. The X is the larger.
The larger
The
group.
larger. Yeah.
The mean of the population, I think.
Yeah, the mean of the larger group. Larger sample.
Okay, so this is asking, X is the
sample mean decrease as the sample size increase.
Result implies that the spread
no,
in X, the spread decreases, so it means that it's normalizing.
Okay, so which of the following results implies that the spread in X decreases as the sample size increases? Okay.
So I think it's a central limit.
Distribution rule.
I'm thinking it's the central limit theorem, because that implies that with the larger numbers, the mean, the X comes closer to the mu. They become very, very close.
But wouldn't that be the law of large numbers?
The law of large numbers has more to do with probability and shape. Central limit theorem is, I think, focusing more on that mean, and the X and the mu becoming more in line.
I think the law of large number is like when the sample size increase, the sample mean is close to the mu. I don't remember.
So with,
are you reading that?
Well, with the notes from last time, I'm pulling them out right now. It'll just be a second.
X is the value. So the question they're asking is, which of the following results implies that the spread in value decreases as the sample size increases?
Center, same definition as non-normals or okay. Shape or gross. Okay, distribution of sample means when parent population is normal to shape or gross of the sample size and shape of the distribution. Okay, I'm trying to look for my notes on that. Okay, so law of large numbers. The greater, it's talking about accuracy. The greater amount of observations in our sample, the sample mean, which is the X with the bar over it, draws closer to the population mean. Well then, or maybe, okay, so maybe I had it, let me read through and we'll decide if I had it the other twisted around or what. Or as the number of repetitions increase in an experiment, the proportion of an outcome observed gets closer to the probability of the outcome. Distribution of, okay. Okay, so that was, all right.
Central limit theorem guarantees the distribution of the value is normal if the sample size
It's large.
of the standard deviation is large enough. No, sample size is large enough. For this course, we require the sample to be greater than or equal than 30.
The law of large number is that as the sample size gets larger, the sample mean will get close to the population mean.
Okay, so that sounds like it is the law of large numbers. Yeah.
Okay.
The spread in X decreases as the sample size increases. So, okay, yeah, I think you're right. I think it is. So I was just looking at, okay, so at our lesson 6, okay, and number 5 on our preparation, the central limit theorem states that if the sample size is large, the sample mean will be approximately normally distributed. That is it. The law of large numbers states that as the sample size increases, the standard deviation of the sample mean will get smaller. So that's right, it's the law of large numbers. Good job, Annie. Annie, do you want to do the next one?
Okay. So scores on the quantitative portion of the GRE are approximately normally distributed with mean mu equal 115.8 and standard deviation is 8.8. Diane earned a score of 160 on the quantitative portion of the GRE. What is the Z-score corresponding to Diane's score? Round your answer to three identical places.
Okay, so she got a score of 160. And we subtract the mean of that, which is 150.8. Is that correct?
Yes.
Yeah.
And then we divide it by the standard deviation, which is 8.8.
So standard deviation. So what I'm wondering is, do we just do, okay, Z-score, it has to be, isn't it the 8.8 divided by,
That's only if you're doing a sample size.
okay. Okay, so we're just doing.
We just
okay.
calculated
doing her score. Okay.
Yeah,
Yeah.
just do the Z-score.
All right.
So that's going to be 9.2 divided by 8.8. Is that what you guys get?
Yeah, so it's the 1.045.
Divided by 1.8.
Okay.
1.045.
Get the
1.045. Okay.
1.045. Okay.
That's the Z value? That's the Z score. What is the Z score? Okay.
What is it? Okay. So we I know it's like, wait a minute, what was the question again?
Yeah.
Okay.
Number 7.
Z-score. We need to.
Number 7, what is the probability that a randomly selected student will score above 160 on the quantitative portion of the GRE? Oh, on the same thing. So we got to plug in the Z value into the applet.
Mm-hmm. And divide by 2.
0.045.
Area.
Area, wait.
1.045.
Above 160.
Above 160.
So it's going to be.
Just the right portion.
Yep, we're gonna click that. Yep, which is 0.148. Is that what you're getting?
That's what it shows. The probability is 0. Wait. 0.148.
Yeah.
Okay. All right, question 8. A random sample of 5 students was selected to take the GRE. Their scores are 160, 175, 163, 149, 153. Do you guys have the same ones?
Yeah.
Yeah, 160, 175, 163, 149, 153.
Yes.
And then we need to calculate the mean of these 5 samples.
Okay. Okay.
Yeah.
This is actually
The
the
mean
sample
is
mean.
160.
Okay, what is the z-score corresponding to the sample
Oh,
mean?
we have to find the sample mean of those 5 scores.
Yeah, the sample mean is 160.
It is?
Because it's based on, let's see, what's it based on? It's, okay, next 4 questions. So we're basing.
Wait. Isn't the sample mean always the same as the population mean?
Yeah, in normal, yes, normal distribution.
Normally, yeah.
Yeah.
Not normal, or is it?
Well, we have to figure out, actually the mean,
Calculate.
we have to go to the information that's right before question 6. Because 6, 7, 8, 9 are, so the mean is 150.8 and hers, they're saying, okay, so they're saying sample mean of these students' scores. So wouldn't it be 160?
We just go back to the applet, right? And then we click on, wait, what does the z-score sample mean? Oh. Okay, so the z-score of this population, right?
Z-score
of the same thing. Okay, so we do it, except we divide by the square root of 5. Is that correct?
Yes.
Okay, see this, all right. So basically it's 0.148, right, is what you're saying. That's the, okay, no, I'm off. Okay, I'm confused.
No.
So say that again, please.
Now we need to calculate the z-score of the sample mean.
Okay.
Not the
So the sample mean should still be the 150.8.
Yeah.
And then we divide by
So what I'm
standard deviation.
Sure?
Well, hold on. So, but the thing of it is in the
8.8.
Look at the formula is
Square
that
root of 5.
so the in lesson 7 is the sample mean minus, let's check.
What's the problem? Okay. Okay, wait, maybe guys, maybe this is where okay, so if we know 160, what is 160? 1.045? That's, so the 160, we know the z-score of 160, right, is 1.045. Where is, so what I'm wondering here is, what's the standard deviation? I'm just thinking out loud here. Standard deviation is 8.8.
Yeah.
Okay.
So they want the z-score of 5 student scores. So there's only one z-score. That's why you divide the standard deviation by the square root of the sample size.
So if 0, if 1, okay. So if the 1.
But I'm not sure about, because we usually take like the value and subtract the mean. So what's the value in this one?
Okay.
Sample mean. I think it's the sample mean.
Random sample
of the population.
Oh, what question are you guys working on?
Number 8.
Group meeting quiz.
Yeah.
Yeah.
Just look at the lesson 7 And the number 3 part, the third part, probability involve the mean. Here.
Well, there were only 5 students selected to take the GRE. Their scores are this. So what does the sample mean? Wouldn't we just add those 5 together?
Sample mean is 160. I just calculate.
Okay, so it's what? So you took all 5 numbers and added those together and divided by 5.
Yeah.
Okay, and that's what you got was 160.
Mm-hmm.
Okay. All right, and then z-score to the sample mean, we know what that is.
So you do the 160 minus the 150.8
and divide with the
divided by
deviation divided by the
square root of 5.
Yeah, square root of 5.
5. Here. 5 square root is 2.236.
160 minus 9.2. Okay. And square root of 5. Okay, so it's 2.236.
2.236.
Okay, that's what I have. Okay, which is 3.9355. So it's 9.2 divided by 3.9355. So the answer I got was 2.337. It goes on.
337.
So 2.338 we put in as a z-score?
Yes. 2.338.
Yeah.
2.338.
Which is
0.0097. Is that what you guys have, the probability?
wait, well,
What's the question?
are we just finding the z-score?
Are we? Okay.
Which
Okay.
is the z-score?
Okay. So what is the z-score? Okay.
Which is very low probability.
Okay. Yeah, very. Okay.
Oh, the random samples.
Okay, greater than mean achieved by the students in the previous problem. The mean was 160. And so we know,
right?
we're going to say they'll have a mean that is greater than the mean. So it would be 0.0097, right?
Greater than the mean. Greater than the mean. 160. Greater than 160.
Mm-hmm. Yes.
Okay.
And we know that 160, the z-score is 2.338, and it's greater than that, so it's going to just be the left side shaded, correct?
Mm-hmm.
Which is you mean the right side?
Yeah, sorry. Yeah, the right side.
The 0.0097.
Mm-hmm.
So it's 0.001. I mean 0.01.
Well, it's 4 decimal places. So 0.0097.
How many are we allowed? 0.0097.
3. Oh,
Well, it says 4 on this one.
Okay.
Okay. So 0.0097 then.
Uh-huh.
Yeah.
0.0097.
Oh, I always forget that. Ooh.
Oh, I hope these aren't all wrong. I just don't feel very confident.
This one I haven't either, but talking it through helps. So.
Yeah.
Suppose the mean GPA of BYU Idaho students is 3.5, and the standard deviation is 0.7, it is well known that this distribution is left skewed. A random sample of n equals 81 students will be drawn.
Oh, I know what I was thinking. Sorry. Because I was thinking that the sample mean is always the same as the population mean, but that's only if the sample is 30 or higher. Is that correct?
Yeah. Mm-hmm.
Okay. All right. I'm with you now. Okay. Go ahead. Number 10. It takes me a while. Okay.
Well, me too. And I didn't know about the 30 cutoff thing. I was just saying, okay, this sounds like a larger population,
Yeah.
but it's nice to have that cutoff. Okay, so what is the shape of the sampling distribution of the random variable x, which represents the sample mean of the 81 students who are selected? So if it's over 30, then we know it's a larger sample, right?
Yeah.
So it's approximately normal. Yeah.
Mm-hmm.
So the mean is 3.5 and the standard deviation is 0.7. And what is the shape? So
it's left skewed. And we know that in left skewed distributions, they will become approximately normal with larger samples as the sample gets larger and larger.
okay. I thought that was right, but okay. Number 11.
Mm-hmm.
What is the mean of the distribution of the sample means? Sampling distribution for all possible samples of size 81 from the parent population. What?
I'm really feeling like that is so poorly worded.
What is the mean? Okay. What is the mean of the distribution of a sample means for all possible samples? All possible samples of size 81 that could be drawn from the parent population.
So it's not 3.5. Do we have to calculate?
Okay, so yeah.
Huh?
Size 81. So okay. All right, let's think about this. So this is a left skewed. So of size 81.
Size 81? We're talking about GPAs.
Well, that's just the
sample size.
Yeah.
Okay.
Sample is 81.
All possible samples of size 81.
Okay, so I know. So this is just the only thing that changes really is the standard deviation. Is that still true when you've got left skewed? Because I'm trying to think when they were showing that one applet.
You mean from last week? I mean from chapter 6?
Yeah. And did they? That's a normal, but that was a normal distribution applet. So, but if it's a larger one, you can apply that normal distribution applet to, even if it's left skewed or right skewed.
I think the sample mean is the same, 3.5.
I think so too. I think so too. That's because I think the only thing that changes is the standard deviation.
Yeah.
All right. Who's reading 12?
Annie, you want to do it?
So, answer for question 11.
The 11
you're still on 11?
3.5.
Oh,
so,
okay.
Because as I'm picturing in my mind, it on the distribution, it normalizes around that mean. So that 3.5, that left skewed, it doesn't matter if it's left skewed or right skewed. As you increase the numbers, it normalizes around that mean. Is that,
Okay.
does that make sense?
The mean stays the same.
Mm-hmm. Yeah.
You have a big enough sample.
Okay, let's go to question 12. What is the standard deviation of the sample means for all possible samples of size 81 that could be drawn for the parent population? Isn't it the same? Oh, it's asking the standard deviation.
Yeah, standard deviation will change.
So this is how do we get that?
So let's see.
Standard deviation is divided by the sample size, right? So it would be 3.5 divided by the square root of 81.
Yeah.
Is that how you find that?
Yeah.
Square root of 81.
Okay, x equals standard. Okay, yeah, because it's the x equals the standard. I mean the standard deviation divided by square root of 81, which is 9.
3.5 divided by 9 is
So
3.078.
0.078.
3.8.
Did you guys
Wait.
0.3888? Is that what you guys have? Yeah,
Yeah.
0.3888.
888. How many decimals do we get? 3 decimals.
Wait,
So 0.9.
isn't it 0.078? You just divide the, what is it? You just divide the random sample by standard deviation.
It's just a random sample.
So
I don't think we need to divide by 2. So
yeah, 0.7 divided by 9 is 0.078.
Yeah.
You're right. I don't know what I was doing.
Yeah, it's not z-score. It's the standard deviation. So you don't have to do much
I divided
work.
the mean. Okay,
Yeah.
so it's by the square root of 81.
Okay,
right?
Yeah.
So I had a hard
0.7 divided by 9.
I had a hard time hearing the conversation. So what is the standard deviation of the distribution of the sample means? Okay.
So you divide the standard deviation 0.7 by the square root of the sample size, square root of 81. So that's 0.7 divided by 9 at 0.07.
Oh, okay.
777. So 0.078. Is that what you guys got?
Yeah, that's what I got.
Okay, yeah, 0.0777. Yeah, keeps going. Okay,
0.078.
Okay.
Welcome, Mackie. I am not looking at the camera, so I didn't know you're here.
Oh, hey.
I did hear another voice there, and I thought, what's going on? I thought it was an echo. It was Maki. Okay.
Yay.
Yay, you made it. How was work?
Good. Slow, super slow. I woke at the library, so.
Oh, that's right.
Yep.
In the morning.
Oh, nice. Okay, so question. Oh, sorry. What is the probability that the mean GPA for 81 randomly selected BYU Idaho students will be less than 3.3? So we have to calculate the z-score and then put it in the normal probability applet, I guess.
So 3.3 minus 3.5.
Yeah, so like a minus.
Oh, that's right.
Yeah.
Divided by
3 minus 3.5 divided by the 0.7 divided by the square root of
what's the sample again? I have to scroll back down.
The 81. So it's the divided by the 0.0777.
So we already calculate the standard, right?
Yeah.
So we just subtract the 3.5 from 3.3.
I
So
got
it's
this negative
negative 0.2
2 point.
divided by 0.078.
Yeah, so I got the answer is negative 2.64.
I'm just kind of, I want to undo the numbers here myself. So it's
So negative 0.2.
Yeah, negative 0.2 divided by the standard deviation we got.
0.078. So negative 2.56.
Yeah, 564.
Yes.
4. Okay.
564. Oh, there.
And this question says less than.
So we should
it's
divide by
only
2.
the left
The
one.
left, yeah. 0.010.
2.554, and then we're just doing the left-hand side.
Mhm.
Okay.
So the probability is 0.005.
0.005, yeah.
Okay. And it's actually, let's see. Okay, this one is 3 decimal places. That's interesting.
Yeah, I know.
Okay. 0.005. Okay.
What is greater than? Question 14 is probability that greater than 3.3. Is it the same answer of
Yeah.
question 13?
Yeah,
It's the opposite.
Yep. So it's,
So you just subtract the number we got in question 13 from 1.
Greater than 3.3.
Oh.
Negative
So
turn to
So
positive.
is that the point?
No.
0.9948?
Well, so yeah, 0.995.
Okay, I need help on this one because
Yeah.
when I see this, the mean of GPA, it's exactly the same, but the opposite, right?
Yeah.
So we are only shading in the right-hand side.
The right hand and the center.
Yeah, that
Because
rest.
And the center.
3.5 and they want to go 3.3 and up.
Okay. Okay. All right. So it's good. Okay. Gotcha.
So,
All right.
yeah.
Thank you. Okay. 0.9948 or 995. 0.995. Okay.
Oh, okay.
That helped.
I got it.
Wait, was that 50? That was 14. Okay. Okay, 0.995. Okay, who wants to do 15? Maki, do you want to do 15 too? Since you're so awesome.
Oh my gosh, that's a long problem, gosh. The United States Coast Guard assumes the mean weight of passengers in commercial boats is 185 pounds. The previous value was lower, but was raised after tragic boating accident.
Oh, wow.
Oh, tragic boating accident.
Wow.
The standard deviation of passenger weight is 26.7 pounds. The weights of a random sample of 48 commercial boat passengers were recorded. The sample mean was determined to be 177.6 pounds. Find the probability that a random sample of passengers will have a weight that is as extreme or more extreme, either above or below the mean. That was observed in this sample. Okay.
48 commercial boat passengers. Okay, so
Yes,
I get
sample size.
177.6 minus 185 divided by 26.7
divided by the square root of
48.
Oh,
48.
yeah.
Okay.
And then?
Come on, Bessie. All right. Okay, 48, square root of 48 is 6.928. 26.7 divided by 6.928 equals 3.854. So 177.6 minus 185, negative 7.4 divided by 3.854. That is that what folks are getting? So I'm going to negative 1.92.
Negative?
Yeah, because 177.6 minus 185 is negative.
1.92.
Negative 1.92. Okay.
So what is the question?
Yeah, really.
So it's
probability.
the way that as extreme or more extreme than was observed in the sample.
So what was the number of z-score?
As extreme or more extreme.
Negative 1.9.
So it's
0.9726.
okay. So it's just extreme, I guess.
As extreme or more extreme.
Because more extreme is above 2.
177.6.
Oh, okay.
Which is below 177.6 is below the mean. So to the left would be, are you getting to the left 0.0274?
So I don't think we have to think about the graph. We just like think about the z-score, and if the z-score is more than 2 or less than negative 2, that's always like more extreme.
Oh, that's right.
Yeah.
We're doing the probability. The p-value? Is that what that is?
No. Yeah, the probability, the area is the same as the probability.
Okay, so what's the rule again? If it's greater than negative?
As extreme or more extreme.
So it means either above or below the mean.
Yeah, so it's
as extreme. That is equal to, as extreme would be equal to or higher, right? Or more extreme. So equal to or higher. We need to determine what is considered more extreme. Is that what?
Oh, so it's not very probable because that's a big
So it just said either above or below the mean.
Wait, find the possibility. I mean probability that random.
You looking for a number?
Okay. So the sample mean
was
okay.
So above. That's above, right?
And more extreme than was okay. Find the probability a random sample will have a weight that is extreme or more extreme than was observed in this sample.
So that's
what was
above
the
average.
weight that was observed in this sample?
Yeah.
The sample mean was 177.6. So
yeah, that's above average.
Okay, and so where is averages? Is it 0?
The mean is 185 and the sample mean is 177. Is that what they're asking? How?
Sorry, I just took it wrong, but we just like put the z-score in the applet, and then we just like see so greater than the 177.6 or the z-score.
Is the 0 177.6 or is the where the z-score is marked is the negative 1.920 where 177.6 is?
I don't understand this question.
As extreme or more extreme, either above or below the mean.
It's above.
Equal to or above? Equal to or above?
It's above, yeah. So what is the z-score again? Sorry, I didn't calculate that.
Okay.
I have the 1.92.
92?
Yes.
Also, we don't have next number.
So that with
means
that
that we're-
177.6, it's the negative 1.920,
Yeah.
right? So anything equal to that or above is what they're asking, correct? Is that, am I reading that right? Is it as,
So the
as
note-
extreme or more extreme?
Yeah. Mhm.
But
Note
when they
that-
say above, don't they really mean further from the mean?
Yeah, they do.
Extreme? Further from the mean.
Yeah.
So
So
we are
both sides. Both
But
sides.
it talks about weight though.
But
Yeah,
it
that's
says
true.
as
Is extreme. So that means like
extreme or more extreme means that we're not only interested in whether they are lower than the one we observe.
It could be both sides. It could be both
Yeah.
sides. Yes. Because both sides are extreme.
Yeah.
They're kind of the outliers.
That's true. So do you add both outsides? So is it 0.0549?
That's what I'm showing. What about
Okay.
anyone?
I think you're right.
So
That sounds familiar. Outside the mean, for lower or above, that would be 0.0549.
0.055.
5.
Yeah.
3 decimal points. 0.55. 0.
I'm super afraid to submit my quiz.
oh wait, pause.
Do you want to
Sorry,
go over the previous
what was the
question?
question 5?
Question 5.
What did you guys get?
We said
Let's
the
just
law
do-
of large numbers.
Oh yeah, okay. Cool. And the 4 is I just put rundown.
Distribution of the sample mean.
Yes.
Perfect. Yes. Whew. Okay, I'm submitting.
Mackie, you want to check our math and make sure we got everything right?
Oh
Second
boy.
chance.
Okay.
Sure. Like go through everything together?
No, when did you come in?
I came in when you guys were talking about question 8, 7-ish.
Oh, okay.
Okay. I'm gonna submit quiz, and if we got any wrong, we could rework those. How's that?
Oh, submit.
How many chances do we get?
Guys, we
Twice.
got 100%. Woo!
No way.
Yes, we totally got 100%.
Well,
Yay!
we're just better than we think.
I couldn't have done it without you guys. That's all I have to say.
Oh wait, so what is question 3? Sorry.
Oh, could someone help her? Because I already clicked off. Oh, wait, I can click back on. So question 3, use the normal probability applet. And so we got 0.175.
75.
What? 0.175.
Oh, 175. Okay, perfect. Thank you. Yay, 100! Woo!
Woohoo! Okay. All right. So does everyone feel okay?
Yeah.
About
I'm just shocked and amazed.
oh my. And just think, like, especially on that last problem, all of that hankering back and forth we did, and we came to the right answer. Woohoo!
I think the hardest part is just trying to figure out what they're asking.
Yeah, the question is sometimes confusing.
What is that size 81 sample? What the heck was that?
The wording on that one was awful, and there was another one too that was horrible. All right,
All
well,
right.
guys, are you guys ready to have a closing prayer and sign off?
Yes.
All right, who wants to say it? If I stop broadcast, can we still communicate?
Yeah.
Sure.
Yeah.
Yeah.
Okay.